Hello, today we're going to be finding area of polygons in the coordinate plane, which is very similar to when we found their perimeter. The key thing is with area, we use specific formulas depending on what kind of polygon we're dealing with. The only types of polygons or shapes you're going to see today are triangles, squares, and rectangles. Formula for area of a triangle is right here, 1/2 times base times height. We'll talk about that more when we see an example. Area, since all four sides of the square are the same, we say the area is the same as side times side or side square. And then for rectangle, length and width are different lengths. The area of a rectangle is length times width. You've probably seen those formulas before, maybe in middle school. It's just been a while. The process, like I said, is very similar to what we did last week. We can find the area of polygons of coordinate plane by first graphing that polygon to see what type of shape we're dealing with, finding the side lengths that we need as necessary, and then finding our area from there. Sometimes we can just count sides like we did with perimeter. Sometimes we'll have to use distance formula. So when you're graphing these on your own, you can either graph them by hand on a coordinate plane, which I'm going to demonstrate here, or you're always welcome to use Desmos for your graphing as well. So starting here with triangle DEF, I'm going to graph D, which is going to be at 1, 3. Go ahead and label that. E, 4, -3. And F, which is at -4, -3. Looking at this, and if it helps you to connect the sides, hopefully you're a better artist than I am. It's a little wiggly, but you get the idea. That's my triangle there. My area of a triangle formula is area equals 1/2 times the base times the height. The base is going to be the side FE, this long side at the bottom. Fortunately, that is a horizontal line, so I can just count how far is it to get from E to F. It is 1, 2, 3, 4, 5, 6, 7, 8. So EF equals 8. And I just did that by counting. I didn't have to use distance formula because it's a horizontal line. My height, which is not one of the sides of the triangle, notice the height has to form a right angle with the base, and it needs to go up to the highest point on the triangle. That height would be this line that would extend between EF and that other vertex D. The height, and once again, is a vertical line, so I can just count units 1, 2, 3, 4, 5, 6. So H, or our height, is going to be 6. If it helps you, we can label EF as our base. So then using our formula for area of a triangle, the area of my triangle is going to be 1/2 times my base number, which was 8, times my height number, which is 6. And as always, you can use Desmos for your calculations, or you can do things by hand. When I do that, I get that my height, or my area of my triangle, is 24. They didn't tell us things like units like centimeters or inches or feet or whatever, so technically it would just be 24 square units, which we can notate like this. Let's try a couple more. So this next one, I'm going to start by plotting it. N is at -1, 1. P is at 2, 1. Q is at 2, or -2, 2. That's a typo. Sorry about that. I found a typo there. Q, please change the coordinates. Q should be at 2, -2, where I have it graphed right here. X is 2, Y is -2. And then R's coordinates are correct, -1, -2. Notice here we have some sort of quadrilateral since we have 4 sides. And if we count carefully, we can see that all 4 sides are the same length. So this is a square. The area of a square is side squared. Since all 4 sides are the same length, I just need to count one of them to find the length of my sides. I'm going to choose NP because it's easy. 1, 2, 3. So NP, which is the length of one of my sides, is 3. So then the area of the squared is going to be 3 squared, which is 9. Again, we don't know units, so it would be 9 square units. Reiterating here, did not need to use distance formula because all of our sides are either horizontal or vertical. All 4 sides are the same length, so I know it's a square. So I can say area is side squared, 3 squared is 9. One last one, graphing this one. K is at -3, 3. L is at +3, 3. M is at 3, -1. N is at -3, -1. So this time we have a rectangle. We know that the area of a rectangle is length times width. I'm going to call KL or MN. Remember, these are the same in a rectangle, so it doesn't matter which one, my length. And since this is a nice horizontal line, I can just count that distance for KL, or the length of KL, is 1, 2, 3, 4, 5, 6. So my length is 6. Same idea for my width. My width, I'm going to use LM. I could also use KN. They are the same, the shorter side. Counting that, since it's a vertical line, 1, 2, 3, 4 equals 4. So then the area of that rectangle is going to be my length times my width. So 6 times 4, which is 24. Once again, units we don't know, so we just say square units or units squared. So find the length of your sides, either by counting or by using distance formula, and then use the appropriate formula to find the area of whatever shape you care about. That is it for today. Have a fantastic day.